Inside almost every phone, laptop, car, camera, and smart device is something so small that most people never think about it, yet it controls almost everything the machine does. That tiny object is a microchip. Modern microchips can contain billions of transistors, all packed into a space smaller than your fingernail. These transistors act like microscopic switches, turning signals on and off at incredible speed. But how do factories build something so small so perfectly, and in such huge numbers? The journey begins with silicon. Silicon is made from refined quartzite, and it is grown into a pure crystal cylinder called an ingot. That ingot is sliced into thin round discs known as wafers. A single wafer looks simple, but by the end it can hold hundreds of chips. From there, the wafer enters one of the most advanced factories on Earth, a semiconductor fabrication plant, also called a fab. Inside the fab is a clean room, a controlled environment designed to keep dust and particles away from the wafer. This matters because even a speck of dust can destroy part of a chip. The wafer does not become a microchip in one step. It travels from machine to machine for months, going through hundreds of controlled processes. Each machine performs one job: adding material, removing material, shaping patterns, cleaning the wafer, or inspecting the work. One of the most important steps is called photolithography. First, the wafer is coated with a light-sensitive chemical called photoresist. Then ultraviolet light is shown through a stencil-like plate called a photomask, which carries the pattern for one layer of the chip. The light transfers that pattern onto the wafer, almost like printing an invisible blueprint at the nanoscale. The exposed parts are then washed away, leaving behind a tiny patterned mask. That mask tells the next machines exactly where to work. Some machines etch material away, cutting microscopic trenches into the wafer. Other machines deposit new materials, filling those trenches with metals like copper or insulating layers that stop electrical paths from touching. After material is added, the wafer is polished until the surface becomes flat again. Then the entire process starts over. Layer by layer, the chip begins to rise. At the bottom are the transistors, the switches that perform logic and calculations. Above them are layers of metal wiring, known as interconnects. These wires connect the transistors so the chip can move data, process instructions, and communicate with the rest of the computer. This is why a microchip is not flat inside. It is more like a tiny city built in layers with roads, bridges, tunnels, and electrical pathways stacked on top of one another. To build a modern chip, the wafer repeats these cycles dozens of times. Every layer needs a different pattern. Every pattern must line up with the layer below it. And every step must happen with extreme precision. Cleaning and inspection happen throughout the process. Special tools scan the wafer to check for defects, broken patterns, or particles. Once the layers are complete, the wafer is sent for testing. Each chip on the wafer is checked to see whether it works properly. Some perform perfectly. Others may have small defects, so they are sorted into different product categories depending on what still works. After testing, the wafer is cut into individual chips. Each chip is then placed into a package that protects it, connects it to a circuit board, and helps move heat away while it is working. Finally, the finished chip is tested again before it is shipped out and installed inside devices like computers, phones, servers, cars, and machines. What makes microchip manufacturing so impressive is not just the size of the parts. It is the precision required to build billions of invisible switches, connect them with microscopic wires, and make them all work together. From a plain silicon wafer to the brain of modern technology, the microchip is one of the most complex things humans manufacture today.